How to troubleshoot multi-threaded apps with GDB. If you are working with multi-threaded applications and facing challenges, you might be wondering how to troubleshoot them effectively using the GNU Debugger. Let's break down the steps to make this process smoother. First off, understanding how GDB handles threads is essential. GDB treats each thread as a separate entity, with its own execution stack and registers. However, all threads share the same memory space. When you are debugging, GDB focuses on one thread at a time, known as the current thread. Any commands you issue will affect this current thread unless you switch to another one. To see all active threads in your program, use the command info threads. This command will display the thread IDs, their status, and highlight the currently selected thread with an asterisk. If you want to focus on a specific thread, you can specify its id as an argument. Switching between threads is straightforward. Use the command thread followed by the thread number. This changes the current thread context, allowing you to inspect its stack, variables, and execution state. This is particularly useful for isolating issues that may occur in specific threads. Setting breakpoints is another critical step. GDB allows you to set breakpoints that can be triggered by any thread or specific threads. When a breakpoint is hit, GDB will indicate which thread caused the stop. You can also use watchpoints to monitor changes to variables across threads. This helps in identifying race conditions or unexpected data modifications. When your program receives a signal or hits a breakpoint, GDB automatically switches to the thread that triggered the event. You will receive a message indicating the thread context switch, which helps you focus on the thread causing the issue. GDB also offers convenience variables like _thread and _global thread to refer to the current thread's local and global thread numbers. These can be handy in scripting breakpoints or conditional commands tailored to specific threads. For advanced debugging, consider using nonstop mode. In this mode, GDB can control threads independently, allowing some threads to run while others are stopped. This is beneficial for debugging complex thread interactions without freezing the entire program. Here are some practical tips for debugging multi-threaded programs with GDB. Always start by listing threads using info threads to get an overview of what is running. Switch to the thread of interest and inspect its call stack using the backtrace command and local variables. When setting breakpoints, think carefully about which threads should trigger them. You can also use thread-specific breakpoints or disable breakpoints on certain threads if needed to reduce noise. Monitoring shared variables with watchpoints can help detect race conditions. Lastly, understanding how your operating system schedules threads and how GDB manages thread stopping and starting is vital to avoid confusion. If your program supports naming threads, use those names to identify threads more easily. By following these steps and commands, you can effectively troubleshoot multi-threaded applications using GDB, gaining control over thread execution and state inspection.